Okay, so the question for this is that you need state transformation. The question asked on the previous slide is used it. So state transformation and graph or plot. Okay, so what is the a value for the first function, y equals negative 2x squared? What's the a value?
Negative 2.
A is negative 2. So since it's a 2, what do we have? Vertical stretch or vertical compression?
Stretch.
Vertical stretch, right? Because 2 is greater than 1, right? Remember, I don't worry about the negative. What does the negative do to my graph?
It's towards out.
What does it do? Reflects, right? So the negative makes it reflect. So if there's a reflection, so when I'm stating a transformation, this is what I have to state. Reflection. And if you want to go a little beyond what is required for this course, you say reflection in the x-axis. Okay? So this is going a little beyond, but I mean, if you are taking the 11M course or if you're taking the 11U course, this is a must. You have to say that it's reflected in the x-axis. Because remember yesterday we saw that the original graph was like this, but then the reflected graph is going down, right? So it's a reflection in the x-axis. And then we know it's a vertical stretch. So I do, when I write this, I usually just do short notation. So I do V stretch, but you guys can write the whole word if you want. Now, what is the normal, regular step pattern for a quadratic? What's the regular step pattern? 1, 3, 5. So you start at the vertex and you go up 1 over 1, up 3 over 1, up 5 over 1. Do you guys remember that from yesterday? Yeah? No? So step pattern for quadratic is 1, 3, 5. But if I have an a value, you multiply that a value by the 1, 3, 5. You guys remember that, right? So the step pattern, which is a times 1, 3, 5, right? So my a is what? The a is negative 2. So negative 2 times 1, 3, 5, which is what? Negative 2, negative 6, negative 10. Do you guys understand that? Okay. As a step pattern of 1, 3, 5. Which means you start at the vertex, which in this case it's a 0, 0, and then you go up 1 over 1 to find your next point, right? And then you go up 3 over 1 to find your next point. And then you can go up 5 over 1. Okay? This is how you can graph a quadrant. This is a shortcut to graphing a quadrant. Start at the vertex and then use your step pattern. Okay? Now, in the case that my step pattern is, in the case that my function has an a value, okay? So in this case, my a value is negative 2. You have to multiply pattern by negative 2. You have to multiply the step pattern by a. What is your a here? 1. So 1 times 1 is 1, 1 times 3 is 3, 1 times 5 is 5, right? But the minute that a value changes from 1, you're going to have to do the multiplication. Do we understand that? Okay. Now, so my step pattern in this case, I have negative 2, negative 6, negative 10. So, I put my graph. Now, what's my vertex for a function that looks like this? We saw these yesterday. We saw them yesterday. What was the vertex for all of the functions that I drew yesterday? 0, 0. Right? The vertex did not change. What changed is that instead of being regular x squared, it became narrower or it became wider. You guys remember that, right? So the location of the vertex or the location of the graph did not change. It's just the shape of it changed, either wider or narrower. Now, so the vertex for this is 0, 0. Now, tell me what's going to happen. What do I have to do in order to get to my next point? What do I have to do? Oh, I made a mistake here. I did not make a mistake. Give me this. I made a mistake. Sorry, I did not make a mistake. Okay, so what do I have to do? What does your step pattern say? What do you have to do? So go down 2 over 1, right? Go down 2 over 1.
It's always over 1?
It's always over 1, okay? So you're gonna go down 2 over 1, so you're gonna end up being at this spot and this spot, okay? Then, how much did I go down?
Go down 6 over 1.
That's right. So from this point now,
Yeah.
I'm gonna have to go down 6, 2, 3, 4, 5, 6. So down 6 over 1.
Oh, 6.
Yeah.
6.
Down 6 from -2 to -8.
Okay.
That's 6, right? 1, 2, 3, 4, 5, 6. So that'll be -3, 4, 5, 6, 7, 8.
Okay.
So I'm going down 6 points, right? And then if you want, you can go down 10. So you're going to end up at -18. Okay? But I don't have room for that, so it's enough. I can draw my quadrant. This looks weird, but it should be. Shouldn't be pointy, it should be more like smooth. Okay?
What is the name for that?
Which one?
1, 3, 5.
It's called a pattern. So this is the pattern for step out for quadratic. So step pattern for quadratic only is A times 1, 3, 5. Are you guys okay with this? Okay. Let's look at the second. Right here. So, state the transformation. I have an A value. What's my A value? 1 over 4, which is 0.25. Right? We all agree? All right. Now, if I want to state the transformation, do I have any inflection? Is the A value negative?
No.
No, so there's no reflection. The A value is between 0 and 1 or greater than 1. Between 0 and 1, right? This 0.25 is between 0 and 1. Because it's between 0 and 1, what's going to happen to your graph? Vertically compressed. So, if the vertical compression or vertically compressed, I will take that too. What would be your step pattern? That's right. So 0.25, because that's your A value, times the 1, 3, 5. Now this is not going to be a fun graph to actually graph, because you're going to have quarters, right, and numbers that are weird. So let's multiply that. What do I get when I multiply 0.25 times 1? How about what, 0.25 times 3? Okay, calculators out. What's 0.25 times 3? 0.75? That's right. Because we're multiplying, we have 3 0.25s together. How about 0.25 times 5? Okay? So my step pattern says that first I have to go up 0.25 over 1. My second step pattern says I have to go up 0.75 over 1, and then up 1.25 over. Now when you're planning your scale here, how are you going to plan your y scale? You're going to go up by 1s?
No.
Or are you going to go up by?
By 20. Or by 10.
By points.
0.50.
0.25. You can go up by 0.25, right?
Can you say that again? What?
When you're planning your scale, your y scale, right? When you're planning how much are you going to go up on the y, you can go up by 0.25.
I thought it was always 1.
No, the scale you pick, as long as you stick with the same scale on that graph, right? So, if I go 0.25, first, 0.25, 0.5, 0.75, 1, 1.25, 1.5. Okay, so I pick my scale so I can fit my points. Do we agree with this? Are we okay with this? On the x-axis, I can go with a regular scale of 1, 2, 3. Where's my vertex? 0, 0. Okay? Now, what do I do?
Go up 0.25 over 1.
Go up 0.25 over 1. So this is where my point is going to be. I can go over 1 to both sides, right? Now how much I have to go up by for the next one? 0.75. So where do I end up?
1.
At 1. Because I have 0.25, 0.5, 0.75. So I have to go up all the way to 1, right? Don't worry about the numbers. You have to worry about what are you going up by. Okay? So from 0.25, if I'm gonna go up 0.75, so I have to go 1, 2, 3. Okay? Over. How much do I have to go up by after that? How much do I have to go up by? 1.25. So where would I end up? 2.2. So I will go all the way here and then over 1. And this is not very clear, but this should be around 2.25, right? Do we get that? How many of you finished day 2 homework? Yeah. Which ones? Midterm research.
And also,
This is what I want you to do right now. I'm gonna, who needs a graph paper? Okay, let me go photocopy some for you. I'll come back and help you with the questions that you had in the homework. What we can do if you guys want, if you have any questions from the homework, I can also take them up on the board. So just get them, you can put the questions that you want. I thought I stopped that. You guys can put the questions on the board if you want, or just wait for me.